Hi, my name's Rita Crompton, and I am here to show you the Trillium wind turbine. The inventor is Rainer Barben, and at this point you can see that we've got the very traditional wind blade that you would see out on the prairies in Wyoming, standing next to the new Trillium wind turbine, and at approximately 3 miles per hour you see that the Trillium blades are fully functional. Now we're going to show you a couple of other test runs that we have done to give you a better idea of how much more functionality there is with the Trillium blade. Right now the Trillium blade is working very well at a low speed, and the traditional blades are not functioning at all. How close do we have to get, and at what velocity now will the traditional blade start functioning, and then how much more speed we're getting actually then out of the Trillium blade. Now our boardroom table that we're testing on is approximately 14 feet long, and there you go. So we have got to get within about 18 inches of the wind source to get the traditional blades to start functioning, and the approximate velocity is 6.1 miles per hour. So huge difference in how soon the Trillium blades will start to function and produce energy compared to the traditional blades. At this point with the close-ups, if you don't get motion sickness, you will notice that there is a significant design difference between the traditional blades and the Trillium blades. It's going to be important to keep in mind that the actual mass of the blades compared to each other is approximately the same. It is the design that is so unique and critical to the production of energy. To give you a bit of a close-up and some details on our Trillium wind turbine, first of all, the nocella actually forces the wind down into the blades now, whereas the traditional mounts do not have any appropriate applications at all for making this more efficient. The blades, as you can see the detail, help to stabilize and actually produce a more efficient spin. From here, where the wind enters the blade, down to where it spins off the tip is a 90-degree push. The traditional blades only have a 15-degree push. All right. One of the reasons why these blades can be so much thinner and more efficient is because of the stabilizing factor that goes in with the bottom piece and spins this around. So the wind goes in, spins off to the end, and it is actually pushing on the blade for the entire time. When the wind enters in off the nocella and it collects almost in this little bowl-like piece and pushes down to the tip, it is acting almost like a jet engine in the fact that it is forcing that wind into a smaller and smaller and smaller area that then creates a more efficient wind turbine blade. All right, for this next test we're going to show you the blades working with a weight on them. We are about 3/4 of the way down our board table. The wind is going at approximately 3.5 miles per hour, and the weight equivalent in with the bucket is 5 split shots, which is a familiar fishing weight, but it will give you an equivalency. And so now we're going to have Reno move the traditional wind turbine down closer to our power source and see how close we need to get before we actually start having power generated.
It's reached 9 degrees.
So for our test, we needed to get up to about 3.8 miles per hour, or just about 2/3 the way down the table. At this point now, we will go ahead and do the same weight with our Trillium
We put
blades.
the marker there.
Now with our Trillium wind turbine out there and at the same distance, all right, instead of the 5 split shots weight in the bucket, we actually now have 14 split shots in the bucket. So would you go ahead and dump the bucket out in your hand so that we can see the weight that is in there? And this is just to let you know that the weights were really in the bucket, whereas the other bucket that was empty. At this point now you can see from the two turbines side by side and tested with weights that the Trillium wind blades are much more efficient. They work at a lower wind speed to generate energy, and they can generate more energy at an equal rate. Now with our wind speed turned up, you can certainly certainly see how efficient the Trillium blades are. So we're at about 4.3 miles per hour.